Okay, well, thank you, old timer, for that introduction. And it's great to be here, and it's great to be following on from Justine, who's rather set the scene really for why we need what I'm going to talk about, which is a strategic review of air quality monitoring that the Environment Agency has been carrying out on behalf of DEFRA and on behalf of ourselves, really, because we do actually manage a lot of these networks on behalf of DEFRA. It's something that's done periodically anyway. If you're running networks, you have to make sure that they're still relevant, that they're measuring the right things in the right places. But there's a particularly sort of opportune moment to do this for various reasons. Air quality's never been more high profile than now. There's considerable squeezing on resources, of course. And also there is a shift from working to EU air quality directives to our environment bill that'll be coming out later in the year. And this is an opportunity to say, well, is there anything we want to do differently with our monitoring networks? So if I could have the first slide, please, or the next slide, please. This is really just a sort of a summary of what the aim of the project is. So it's quite simple, doesn't it? To ensure that the UK's publicly funded air quality is meeting current and projected needs as effectively as we can. But there's actually quite a lot to unpick in here once you start looking at it. So first of all, what are all these activities that we're interested in, the monitoring activities? Who's running them and why? What are those current and projected needs? What technological opportunities have arisen since we last did this review? What new resources, new tools have become available? How might we improve efficiency by synergies across the network? Are there some things we're measuring twice that we could make better use of? And then there's the data itself. It's a huge mine of information. We've done some great things with it in the past, but there's even more potential for pulling those data together and extracting even more value from them. So on to how we actually did this then. In the next slide, please. So the first phase of this, it's actually envisaged having 3 phases, and the first phase is what we've carried out, and this is the foundation, if you like. This is looking at those first questions that I presented. This baseline, we need to know what work is going on. We need to collate what needs are. We need to tease out what people really need and what they don't need, what are nice to haves, what are essentials, and we need to compare those needs and provision to meet those needs to see if there's any mismatch or shortfall between them. We need to look at the technology and the data management opportunities and look how we can extract that maximum value from the data that we have. And then this phase 1 ended with developing some quite high level options about how we might go forward, and those can be taken in the next phase, hopefully, resource permitting, to come up with more detailed designs in terms of the specific when and where and how. Slide, whatever, please. Next slide, please. So first of all, then, the stakeholder needs. This is, as I say in the slide, it's non-trivial. It's actually really difficult to find all the people involved. And this isn't for any, there's no cock-up or sort of incompetence here. It is simply the way the networks have grown in a very organic way, with multiple people commissioning them over time. And that's, it's just the way it's gone. One particular community might need data on reactive nitrogen depositing to soil. Another might need exposure information for people in a city. But there are opportunities there to bring some of those needs together. And at the moment, as you'll see, we have 12 networks run by government specifically. There's a whole sort of alphabet soup of different networks there, looking at the automated urban and rural network, the PAH network, the toxic micropollutants network, etc., etc. In addition to those, there are 400 local authorities, all of whom have different approaches to doing what they do and different pots of resource and different local challenges. So it's how do we pull them into this unified system? And then, of course, research. There's an awful lot of what we do depends on good background research information. How do we know how harmful things are? How do we know what are effective mitigations and so forth? And there've been various recommendations coming out that we do need a much more joined up approach. I mean, it's a no-brainer really, but the National Audit Office and the Clean Air Strategy have both pushed this forward. That not only are there great benefits in what we can measure, but there are also savings in how we can do it, to be frank. Okay, next slide, please. So this was from talking to a whole load of stakeholders. We had a fantastic secondee from University of West of England, Ben Williams, who worked brilliantly on this side of the project, putting out surveys and organising workshops with stakeholders and finding out what it is that they're actually needing monitoring for. And of course, there's the obvious, there's the compliance with regulations, the sort of things we're putting in place to reduce harm and making sure that people are sticking to those. What interventions are actually working? You know, we've heard about the clean air zones, for example, and it's, as Justine said, it's monitoring data that's ultimately showing whether or not those are doing what they say on the tin, that they are making a difference. So it's important that those monitors are in the right place, measuring the right thing with the right level of certainty. Impacts, of course, we need the epidemiology for human health and also the impact on natural capital, which is a big thing at the moment, that sensitive habitats are not just pretty, they're not just, you know, oh, here's a nice flower meadow or a bog or whatever. They're actually delivering services for the environment. They're capturing carbon, they're close to the Environment Agency's heart is they're moderating water flows. So if you're, for example, losing all your upland sphagnum moss and bogs, then the water's going to come down much more rapidly from the mountains and cause a lot of damage. So these aren't nice to have. These are really important parts of protecting our natural capital. Information, that's an interesting and changing sort of area. There's an awful lot more demand now at the public level for information on the air quality they're being exposed to. So we have to be able to provide information in a form that is delivering what people need. It needs to be summed up in appropriate ways, presented, made accessible, be transparent so that people can actually trust this information, that we're not trying to bury any bad news or anything like that. So a big part of the information challenge is doing that. It's getting the information out to the right people in the right form and making it accessible. And the flip side of that is, yes, you're giving people information so they can protect themselves, but you might also be influencing their behaviours. They might think twice about driving to drop the kids off or joining a walking bus to drop the kids off and this kind of thing. So you're actually starting to nudge people's behaviours by making it really obvious to them what the impacts are. And I've mentioned research already, that there's all sorts of research activities going on. And some of those can actually sort of inform each other, and some of them make use of the formal network data, and some of the research data can actually help us better understand the formal networks. Have the next slide, please. This one shows some of the examples of the specific things that cropped up in those meetings. So, in particular, for impact assessments, there's a need for greater spatial and or temporal resolution. You know, we need to be monitoring in a more finely grained way. And this is a really interesting one to pick on because it's a time when there's great potential for actually doing something about that. I'll talk about that shortly, but in a nutshell, we are now at a position where we can get much better spatial coverage using some of the lower cost monitors that you'll be hearing about in the next 2 weeks, and which Jim and colleagues are working hard on standards for through CEN, I believe, and actually setting up a way of assessing these monitors, so it's not the Wild West that it is currently, where people are selling all kinds of either successful or rather dubious monitors with little way to tell what's what. But these are really having the potential to fill in some of those gaps in assessment. The thing right at the bottom there is monitoring specifically to improve modelling, and that might seem an odd thing, but the reality is, in doing our air quality assessments, that the modelling and the monitoring go hand in hand. We can't monitor every square inch of the country. We have to interpolate between those points, and it's not necessarily a straight line between the concentration here and the concentration here. It is, there may be fluctuations within there. It may be a non-linear relationship. And so we need to work hand in hand with modelers to decide where their greatest uncertainties are, and to target our monitoring at the point where we can make the biggest impact on that uncertainty and bring it down to a level that is acceptable and that can feed into the models, this process of data assimilation, to produce an overall better quality, lower uncertainty air quality assessment. Okay. The next slide, please. I thought it wouldn't be a complete talk without getting in one of these nice 3-word slogans that seem to be de rigueur at the moment. So for monitoring needs resolution to get the right level of granularity in our data, integration to pull together all the different networks that might add value, and complementarity. And this is about getting the data in a form where different people can use each other's data. Again, Justine touched on the value of metadata, the information that describes the data you have. And unless you have access to all those metadata, you can't reliably make use of somebody else's data. So that's an absolutely crucial part of this process. Next slide, please. So down to the nitty-gritty of instruments. Again, we try not to prescribe instruments and say, right, all the network will have this one particular instrument, unless there's an awfully good reason for that. I mentioned a bit further down, putting all your eggs in one basket. Do you rely on one supplier, one instrument, or do you cover all the bases by having several different instruments? The downside of that being that they might have slightly different behaviors, they might read in slightly different ways. And the importance of that, then, the important thing to do if you do go that route, or indeed if you're sticking with one instrument, is to understand all the nuances of how it responds to pollutants. What are its strengths and weaknesses? For example, we're looking at PM 2.5 monitors at the moment for an extended PM 2.5 network, separate piece of work. To support the Environment Bill, which is going to include some sort of limit targets for PM 2.5. And some of the instruments work better in some types of site, some better in other types of site. And when I say better, I mean closer to reference methods, which themselves have certain flaws. So it's really important to understand the differences between those instruments and to have evidence of their performance, so this formal equivalence process. That said, I'm moving up this list now, there is this requirement to have specifications very openly available so that people in the market can innovate, they can develop new devices that meet those specifications. So it has to be absolutely transparent what's needed. And a practical thing at the bottom there, if a wonderful new instrument comes along, we don't immediately go in there and replace all the old instruments. A, we can't afford it. And B, there's a downside there in that there's risk of a new instrument, and there's a risk of discontinuity in data. If one instrument measures slightly differently from another, you might get a sudden stepwise change in apparent concentration. And very often it's the change that's more important than the absolute value when you're assessing the success of a mitigation measure. And of course, there's a big disruption to the system when you put new instruments in. So there has to be a regular review built into the network process to look at instruments, but also to schedule when they might come into play down the line. Next slide, please. A couple of trends that have emerged looking at the new instruments, and we're doing this review. Very much what you'd expect. The distributed networks are supplementing the reference methods in quite a lot of locations. People have said, well, the reference methods are plus or minus a few percent. The small, low-cost distributable sensor might be plus or minus 20%. So are they really any use? Well, if you look at the concentration map estimate, say across a city, then from meter to meter, you're going to get quite large fluctuations in concentration due to the multiple sources, the airflows between buildings and so on. So a device that can offer plus or minus 20% is actually offering a considerable reduction in uncertainty in spatial concentration. So these devices really do have an important place to play, and we are looking at how they can be included in systems. To some extent, we already do this with NOx diffusion tubes, but of course they don't have the temporal resolution to show fluctuations, say, in daily traffic patterns and this kind of thing. Remote sensing, that's very much becoming a reality now rather than a sort of a Star Trek fantasy. We are looking at we already use these data for things like land cover mapping. We have LiDAR telling us within a few centimeters what the height of the land is, so we can look at flooding problems. We're getting to the stage we now can see from space discrete large plumes, such as traffic plumes or a very big industrial process. And we've done some interesting work recently in the agency looking at detecting ammonia sources at quite fine resolution, talking kilometre grid square sort of resolution, that can now be used to ground truth models of concentration of ammonia across the UK. So they are becoming viable. So watch this space on those, I think. Personal monitoring, of course, is giving individuals some agency over determining what they're exposed to. And I mentioned before, potentially nudging their behaviours to reduce exposure. Next slide, please. So there are some good moves already towards data integration, and DEFRA's putting resources into data warehousing. The UK Air website, a lot of you will be familiar with, is a superb resource. I, for one, with my academic hat on, have used it endlessly as a sort of a repository of data to mine for student projects, for research projects. And of course, anybody can look up their pollution challenge anywhere they like. But there's more that we can be doing with those data. And we have the resources to do that in the country through Science and Technology Funding Council, for example, have big data storage and computing capacity. And they're used to dealing with massive streams of data from satellites, not just the few gigabytes that we generate from the network. They're very keen on this FAIR approach, which I've mentioned: findable, accessible, interoperable, and reusable. And the philosophy here is that you put all of the data you can onto the network with appropriate metadata so that anyone can go in there to the maximum resolution of that information and make use of it. At the same time, you can bolt on different front ends, which are effectively little sort of processing engines that will pop out individual numbers that might be the sort of digest that people need to make decisions or to look at their own exposures. So yeah, let's make use of all the data, the highest space of resolution we've got. And the next slide, really, this is the summary slide. The development of options that came out of all this process fell into four categories, depending, if you like, on the ambition and the resources available to look at air quality. Option one isn't no change. We decided that wasn't an option at all. We do need this continuous improvement in terms of instrumentation and in centralizing data as well. That's stated policy from the government with the clean air strategy. So option one is the minimal changes. It's just updating, refreshing the networks, and having a move to more centralized data. In option two, we can go to some greater development and rationalization. We can really start to match the network better with the current needs and with the current resources available. And when I say apply rational design there, I mean actually take a statistical approach, a rigorous statistical approach. We don't want to say, oh, we can afford 100 monitors, we'll scatter them here, here, and here. Let's work out where those 100 monitors are going to make the biggest difference in terms of reducing uncertainty, down to a fit-for-purpose level. It doesn't have to be perfect. It has to be enough that you're making decisions in an informed way and not under risk or not under unacceptable risk. Option 3, we can be a bit bolder. We'll spend a bit more money, but we'll use new technologies and better integration and really develop the benefits and deliver the benefits that current infrastructure can't, of everything being joined up and accessible. And number 4, of course, is the Star Trek option. It's no constraints. You throw all the money that you can at it. And I think that's probably not the one to go for 2 reasons. Firstly, because we couldn't afford it. And secondly, because it's diminishing returns. I think if you start going to these extremes, then the amount of information you get for each pound spent is leveling off. It's becoming asymptotic with nothing, basically. So options 2 and 3 are the ones that we've really pushed forward for, and for which bids have gone into SR21 and so forth to get the resources to do that. And you'll see there's been a stepwise process to bring us to this point. And the options themselves, I know I haven't given concrete examples, but we've actually costed concrete examples for the options of what we would need to improve ozone, to improve PM 2.5, PM 10, etc. So there's a lot of solid recommendation in there. If the next phase goes ahead, we'll be able to develop those in more detail and come up with a short list and some outlines of how specifically monitor sites will be chosen and this kind of thing. So the statistically robust approach and a detailed governance plan, of course, to make sure that we do try and stay on top of changes, changing needs, etc. As I mentioned, there is a process of review. Let's put that on a very formal footing. Let's try and join up between all the people that Justine has been dealing with in JACU, plus anyone else, local government and so forth, who are working on air quality, and make sure we're doing it, a one-time process of monitoring air quality for the UK. And the data management plan, let's get that so that this very, very valuable product that we're producing, we're absolutely making the best of. And I will stop there. Thank you very much for listening.
Thank you, Rob. I don't envy your task in reviewing these networks. As you say, they're extremely complicated and numerous, and all run by different agencies or parts of companies as well. It's a task which is really quite difficult. A couple of questions, if you don't mind. I mean, one of the things you mentioned was distributed networks or small sensors or low-cost sensors, whatever name we want to give them. A lot of these are already being used in research projects and by local authorities across the country. Do you have any picture in your head as to how we might see these being deployed in the national networks at some point, and what job do you think these sensors should be doing in a national framework?
We have actually included them in both our options 2 and options 3 because, as you know better than most people, Jim, they are getting to this stage where they are reliable to a defined level of reliable, which is what you need for a network. So we do see them as part of the, for example, assessing air qualities in cities where you do get these very steep gradients of change, and where you're trying to work out individual exposures as they move through a series of microenvironments. So we do see that, the classic sort of sun and planet type arrangement with the reference monitor in the middle, and the pretty well proven now dispersed monitors providing some of that spatial fill-in. It's interesting that you mentioned the research use they've been put to for a long while. And you look at a project like Breathe London, where this, was originally started out as a research project with all manner of different monitoring systems. It was fantastic. Integrating those data together, it was almost a microcosm of everything we're trying to achieve nationally. And it's interesting how that is sort of shimmying into operational use, into providing information for the local government. Almost, it's almost a stealth engagement of these low-cost sensors, which I think is fantastic. I've met a certain amount of skepticism, shall we say, amongst some colleagues. I've been banging on about these for about 20 years, and it's been an uphill struggle persuading people that they are a real thing. And it's having case studies like Breathe London that I'm able to say, well, look, guys, this is a reality, and we're now in a position of playing catch up rather than leading the field. So I don't know if that answers your question, Jim, but I think they are a certain part of the future, and the near future rather than the far future.
Yeah, absolutely, Rob. And, we have a session tomorrow at the conference dealing specifically with these small sensors in terms of their certification under CEN, which
Yeah.
we're still paying heed to, even despite Brexit.
Mm.
But I think possibly the UK, the UK has been at the edge, cutting edge of the development of these technologies. And perhaps there's an opportunity here for the UK to move a little bit faster in adoption and the use of these technologies, in that we are no longer required to have the consensus of all the other member states in moving in that direction. So that's maybe one good thing that will come out of it, and we'll explore that tomorrow. Another question I'd like to ask is has the national network in any way considered, especially when you mentioned monitoring and modeling synergies, and the fact that these two actions need to work closely together? The models all need emissions factors as well as observed concentrations, and therefore they measure CO2 ratios with all of the other pollutants such as NO2 and PM and SO2 and the like. Why don't we measure CO2 in the national networks in order to get a better information about emissions ratios rather than simply looking at observed concentrations of criteria pollutant?
Crikey, that's putting me on the spot, Jim. I think
Well, I know you're up to it, Rod.
absolutely, absolutely. I mean, it's interesting that you do get this split at the moment between air quality and climate change in various bits of government and also academia. They're two very distinct communities, and there are a few overlaps, like we'll be hearing from Rob Jones, I think, at some point. And the guys I work with at Cranfield actually are active in both spheres. So we need more overlap between those communities because they are obviously interested in CO2 emissions. That said, it's anything that depends on ratios between pollutants is quite tricky because those ratios are so variable. It used to be that we considered when we only had PM10 monitoring, we would consider PM2.5 as 0.7, 70% of that mass. And that can vary enormously from 60% to 100%, for example. And there's a shift now to decoupling even those two, decoupling them and not assuming a ratio. So if you're having to do it there, I think it's even harder to do for less closely related pollutants. There may be some correlation between NO2 and PM2.5, probably closer than PM2.5 and PM10. But more of our efforts put into teasing apart the differences between pollutants than looking at combined effects. Is NO2 actually bad for people, or is it because it's tightly correlated with PM2.5 that it appears bad for people? So Again, I have to give this more thought, but I don't think using any pollutant as a surrogate for another is a terribly safe way to go.
Thanks, Rob. Just to clarify, the reason the question's coming up is that we have Professor Ali Lewis from Chair of AQUEG tomorrow talking about synergies between climate change and air quality. We have Ron Cohen from University Berkeley in California, who's doing some really interesting work on CO2 gradients in Glasgow around the COP22 conference and beyond. And as you mentioned, I think Professor Jones from Cambridge tomorrow is going to touch on some of these issues. And it's about really trying to understand the relationship. When we burn any fossil fuel, CO2 is emitted, but also the pollutants that we're familiar with in the network, PM2.5, PM10, SO2 sometimes, but certainly NO2 are all emitted. And it's looking at the ratio of the primary CO2 to those pollutants, which can give us an emissions ratio. In other words, how clean is the combustion? And of course, the modelers are very interested in that, but it's something that the National Monitoring Network has never really looked at. And it's now so low cost to measure CO2. It's something that I think we perhaps should be giving some consideration to, but we'll hear about that tomorrow, I'm sure.
You know,
Well,
when you put it like that, Jim, it is a no-brainer that we can just stick a CO2 monitor in each of the sites that we're monitoring the other pollutants, not as an alternative to measuring the specific pollutants, but as something that provide a lot of additional information, both
yeah,
in the, as you say, the cleanness of burn, but also for the climate people.
I think that's the point, Rob. And again,
Mm.
let me just bring this to a close and thank you again with my individual round of applause
Thank you.
for your contribution this morning. I found it incredibly interesting to find out what the thinking is behind the networks. As someone who's been involved in them for the last 30 odd years, it's good to see that things are moving forward in such a progressive manner.